All right, guys, we are coming up to the most important lesson that I think you guys can learn here. And if by the end of it, okay, you actually use this information to start saving, like right now, you guys will, I should just straight up give you an A. Here is what's going on, okay? Now, interest rates are pretty low in the United States at the moment, though they are going up. And so finding something with a 5% interest is pretty unlikely, at least for classic savings. If you just invest generally in the stock market, that's going to be something similar. But here is a idea on compound interest. Okay, so when you are doing a compound interest, it really starts to explode after a while. Okay, so the first year you get 5% on $100. Okay, and so now you have $105. Okay, so 5% or 0.05, right? 100 times 0.05 is going to give you $5. Okay, or yeah. So your total will be $5 when you all said and done. And the $5, well, really, it'll give you 500, and then you move the decimal over, and it gives you $5. So you're making $5. Great. Now, the next year, though, you're not doing 5% on $100. You're doing 5% on $105. And so now you make $5.25. Great. Okay, slightly a quarter. That's big whoop. After 2 years, though, you now have $110.25. So instead of doing 5% on $100, now you're making $5.51. Okay, 50 cents, 51 cents, still, I don't know, barely anything. Bubba barely worth it. You've made a total amount of dollars of, at this point, after 3 years, you've made $15. 3 years of your money sitting in the bank, and you've made $15. That seems like a waste. However, here's the deal. Here's why it gets so important, okay? This money continues to grow. So, after 3 years, okay, you have starts to grow. Let's see, what exactly are they showing here? So 3 years, you're at $115. After, what are they doing simple interest here? What are they trying to show? Sorry, I want to... I'm trying to figure out this graph, the simple interest versus compound interest. Oh, sorry. Okay, I get it what you're saying. They're comparing simple interest versus compound interest. So in simple interest is where the $100 at 5% interest. So this is every year you're only making that $5. It's not compounding. It's just the interest on $100, and that's it. Okay, so that's what simple interest is. Just every year you make $5 if you put in $100. So for 3 years, that's $115. Or you're at $115. You've made $15. After 10 years, you've made $50. After 20 years, you've made $200. After 30 years, you've made $250. 40 years, you've made $300, which you've made $200, right? Because you had 100 to begin with. And then at 50 years, you are left with $350, or a total new money of 150 bucks, 250 bucks. Over here, this is saying that same $100, same 5% interest, except this is compounded, which means that every time you get more money, the new money is also included in the interest. Okay, so first, it's barely any different. Okay, you start to see a little bit of difference here, right? About $65 and more. Over here, it's really pulling away. Okay, about $200 more. Over here, it is more than double. And then over here, it's insane. Okay, because the money keeps growing, it gets bigger and bigger, really fast, or eventually. It takes a bit to get it rolling, but once it starts rolling, it goes really big. Okay, so most calculators can calculate compound interest. Form the calculation in example 1 by using multiplication sequence. If you do not have a normal calculator, you can go over here to Google. Okay. So 100, where are you? 100 times 1.1, okay, times 1.1 times 1.1 times 1.1. Okay, and every time you do that, you take the new number and you're multiplying that by the new 1.1. Okay, every year. I only did this a few times. Okay, we started at $100, and just with 0.1, well, 0.1 is 10% interest, so that's really good. With 10% interest, we're already at 161. It's going to really start to get big here pretty soon. Now, if we're adding it by 10% interest, why aren't we just timesing it by 0.1? If we're timesing it by 0.1, we would find the total interest gain, $21 of just new money being added. But the problem with that is you are messing up. Go back to our old one. The problem with that is you are losing in the calculation your initial investment. Okay, so you would have to take this number and add to 1.4358881 in order to find your new answer. So you always want to include times 1, which is itself, and then the addition of 0.1. That is the total. Okay, if you just multiply it by 0.1, the 10% interest, that is just giving you how much money you've earned without including your initial investment. And you want to, for compound interest, you're including your initial investment plus the money you've gotten. Okay. You can change these factors instead of doing it like, let me switch back. Going back to the book, instead of doing it separately, you can use it as a factor. Okay. And some calculators will allow you to do that faster. The rule of 72 is essentially when you're using compound interest, okay, the entire number should basically double, or take the growth rate. 72 divided by the growth rate is how long it takes to double. Okay. So 72 divided by 6 is 12, which means your initial investment of, say, $100 will double in 12 years. Or $1,000 will double to $2,000 in 12 years. Okay? So 72 by whatever your interest rate is. Okay? What does all of this tell you? Well, it should tell you two things. The most important thing is to start early, okay? In order to get your investment of $1,000 to continually double, you need to give it time, lots of time, okay? And time is something that you have a lot of right now, but when you're an old miser like me, you don't have a lot of time, okay? I could die at any minute now. I'm so old and ancient, decrepit, really. And as such, I don't have a lot of years left to grow my investments. You guys, however, are young. You're in the prime of your life, and you guys have plenty of time to grow your investments if you start now. Okay, do not waste, do not slow down. If you guys go ahead and invest some money and start it in a compound interest early, you guys are going to be very, very well off. Okay. For instance, I started when I was 18. I started what's called a whole term life insurance policy. My brother's life insurance salesman, and he sold me on it. Now, the life insurance policy is fine. If I die and my folks get $20,000, okay, that's all right. However, the whole term in life insurance policy, you're able to pay extra into, and that money you pay extra, it compounds it compounds. It gets bigger and bigger. When I retire in my 60s, okay, say 64, I will have, and I will be able to withdraw about $80,000 out of my life insurance policy. My life insurance policy alone will be worth $80,000, okay, which is pretty okay for putting $30 a month, $32 a month in. Okay, so every month I pay $32. That money is then compounded. Okay, I mean, some of it pays for my life insurance, but if we go ahead and let's see, 32 times 12, okay, 384. So I have 384, and let's say when I'm 64 minus 18, this is how many years? 46 years. So 46 years, 384 times, what's it, 46? Okay, 17,664. That's how much money I would have saved if I just put that in every year. I just took $32 every month. I put $32 and I just put it into an account. Okay, just a normal banking account. Now, this would get some amount of interest. Okay, very little, probably 1%, if that. Okay, so to really see this, I would have to, each year, I would have to do this calculation slightly differently. I would do 384. Let's write this down, or we'll go over here. To really see it, I'd have to do 384 times 1.01. That's how much I have after the first year. Then I would add 384 again, and then times that by 1.01. And I would have to do that, what do we say, 46 years in order to really see what, my money would be. But it would still not be all that much. It definitely is still a lot smaller than the, 80-something $1,000, 1, 2, 3, that I will have using compound interest, putting $32 a month into my life insurance policy. Okay. So this is exceedingly good. These are the kind of investments you really should try and find and do early. Okay. You could talk to your parents about whole term life insurance now if you wanted to. You could talk about other savings accounts that give you compound interest. Okay. You could do a quick Google search about where can I get compound interest. Okay. CDs, okay, certificates of deposit are used banks. They have higher interest. CDs, their main thing is that you cannot, and high interest savings accounts do it as well. The main thing with both of these, as well as bonds, bonds don't really give you that much compound interest, really. Stocks do, bonds can. Stocks are, if you put into something like an index fund, is pretty safe. But these two are generally the most safe. You can get compound interest, and all you'd have to do is put 100, 200, maybe even 1,000 now, and your money will extraordinarily grow by the time you are old and decrepit like myself. Okay, that's what this is trying to show you. Okay, and here it's got a good thing for you. Here we go. This guy here. Okay, linear growth goes up really big. So this is linear growth is, for instance, you gain $5 every day. Okay, or we'll say $100 each day, right? Every single day you get $100. It just grows up slowly but surely. Okay, but if you have the option of somebody giving you $100, we'll say $1,000 every day, $1,000 every day for the rest of your life. Okay, versus somebody giving you, well, we'll make it nice and easy. We'll say $1,000 for a month. Every day you get $1,000. Versus somebody who gives you a penny, and that penny will double every day for a month. Okay, so we are comparing. Let's get back to here. $1,000 times 31, okay, equals $31,000. Pretty dang good. Versus getting a penny one day, 2 pennies the next day, 4 pennies the third day, 8 pennies, and so on. Okay? It seems like this would in no way possibly catch up. But even though it starts out really slow, I'm actually going to switch to a calculator for the 60 for this. So we're at 1, 2, 3, 4, 5, 6, 7. 0.64 times 2. Oop. 0.64 times 2, right? So 8, 9, 10, 11, 12. Oh, shoot. How do I go back? 12, 13, 14, 15, 16, 17, 18, 19, 20. Now by day 20, we're now making double what we would be making, almost triple what we'd be making the other way. Now, is that enough to make up? 20, 30, 40, 50, 20, 25, 26, 27, 28, 29, 30, 31. That is a much bigger number than the $31,000. Okay, exponential growth, compound interest. These are the things that are insane when they explode. Right, much bigger. Starting with a penny that doubles for 1 month is bigger than getting $1,000 every month. Okay, or every day. Let's see. Anyway, if you guys go ahead and invest in anything that has compound interest, or convince your parents to help you invest in anything that's compound interest, let me know, and I'll give you some bonus points because, heck, invest in your future, guys. But for this, you don't actually, it's not required. Just go through this, do all of the parts 1 through 11, and that's what I got for you. Anyway, really important to talk about your future, which is why I did that and spent more time than you probably wanted me to. But anyway, have fun.